3. Okay. Number 23. All right, so we have our poor excuse of a cube written up on the board. They tell us that one edge of the cube is represented as x plus 1, and then in order to find the volume, so being a cube, you have 6 faces that are all the same, and then all the edges are the same. So in order to find the volume, you take the edge and you cube it, which is the edge is x plus 1. You cube it, and you have to realize that that's the same thing as writing x plus 1 times x plus 1 times x plus 1. So I'd be okay with any of those for the volume of a cube. Should you multiply them out? I don't see the benefit of doing that, but I don't think I'd do that. And then what would the volume be if we knew that x is equal to 3? Well, you can plug 3 into any one of these locations and get an answer. So 3 plus 1 is 4, so I get 4 to the third. So 4 times 4 times 4 is 64 cubic units. Okay? That's how I would go about that one. Any other questions on? Yeah. 25. Hold on. 25 says, find the sum or difference and classify the result by degree and number of terms. Okay. And I thought we'd have a new bulb. I apologize that this is taking so long for them to figure out. You good, B? Yeah. 25. All right, so I'm going to rewrite it. I'm just going to drop the parentheses on the first one, so I get 4y to the third plus y squared minus 5y minus 17. And then the other one I have to distribute the parentheses, so I'm going to get minus 3y squared plus 12y minus 6. Okay, so the ones that are blue, they are all, those signs had changed because you had a negative corresponding to those. Missing anybody else? Jacob didn't come, did he? Other Jacob. Hang on, Sam. I'm not done yet. Next thing I can do is let's combine like terms. So I get 4y to the third. Combine those, so I get negative 2y squared. Combine these. No, I didn't mark it. Plus 7y. And then combine these. Minus 23. So this is a third degree polynomial. Okay, why is it third degree? Well, the highest exponent is 3. Polynomial because you have 4 or more terms. Anything else? Yeah.
So for negative 3 minus second power, since it's changing, would it ever be like plus?
If it originally had been a minus and you distribute the negative, absolutely. So if in the parentheses it already said negative 3y and you're already subtracting it, then you distribute that. Okay. Anything else? All right. Make sure your names are on those. Pass those forward. Yeah. Which one? 21. Multiply it. Double distribute. Yeah. What is it in the building?
Yeah.
Yeah, go get it. I'll wait for you. Good.
How's your weekend?
Good. enjoyed my family. What about you? Oh, yeah. Anybody else? Jake, put it away. All right. Let's see. Annie, this came for you. This came for you. Jax, Brandon, this came for you.
Would you rather have dirty hands? Eat dirt? No, you're not. Mr. Sharp, are you supposed to eat germs?
It helps your immune system. Like if you sanitize all the germs away, then your immune system is going to be awful.
You're referring to germs as bacteria.
Yeah, see, I'm from red.
Perfect, thank you.
Jacob, I just collected page 45, 46. That would have been assigned on Thursday. And then if you needed extra time, you do it. All right, find your seats, everybody. All right. So we are starting into something called factoring. And factoring is just undoing multiplication is really what all it is. So let's see. Our first one to start with, we're going to multiply. So problem 1, 2, 3, and 4, we're doing the distributive property. Thank you. Oh, he's never here, ever. Like I saw him once first semester.
Okay.
So let them know.
Thank you.
Okay. All right, Presley, grab your stuff. Yeah.
No, I didn't even do anything bad. Presley, what? No, why would you don't take her away? Oh my
You can take that one too.
No, one second. Okay, I love you. I don't want things. Literally, I'm just
Oh, good. The police are even out in the hallway too.
Are they really? Oh my.
Go. Let's go. Come on.
I'm sorry, guys.
Shouldn't be that hard. Grab yourself and go.
I'm sorry.
There you go.
Have a great day.
It's all recorded for you if you want to listen. Your earbuds are hanging out.
Thank you.
It is. All right. Here we go. Shh. So let's distribute over the parentheses. We've been working on this. Eventually, we're going to work backwards from this. So this gives me 10x squared minus 20x plus 15. That's it. Okay, we've done this. We've worked this. Okay, the next one, if we distribute over 3x over the parentheses, I'm going to multiply, so I get negative 12x to the third. Remember when you're adding like bases, you add the exponents. And then plus 6x squared minus 3x. Okay, so this is stuff we've been working on. This is so last couple of weeks. Next one, we're going to distribute the negative 2x over the parentheses. this many times, so I'm going to get negative 2x to the fourth minus 4x to the third minus 3x to the second plus 8x. Okay? So again, we're just distributing over the parentheses in order to get a reduction of terms. And then the last one, if I multiply 3ab here, that's going to give me 6a to the third, b to the second, plus 9a squared, b squared, oops, I ran out of room, minus 12a squared, b to the third. That's a b to the third, sorry about that. Okay, so again, this uses the distributive property, which is the same exact thing as multiplication. That's what we're getting to. But what we're going to start working on with this is we're going to start undoing it. Okay, and so when you undo it, there's times that all the terms have a number that goes into all of the numbers, or all of the terms have all of the letters, or anything like that. Thanks, sir. Okay, so let's see what.
I had a question on the last part. It says 6a.
I'll write it more clearly for you. 6a to the third b squared plus 9a squared b squared minus 12a squared b to the third. That's the answer that I didn't have room to squeeze.
Thank you.
Surely.
Name's not Shirley.
Okay. Never mind. All right. So, factor to write as a product of two or more terms. Okay? So, if you wanted to take, say, the number 6, you know the 6 is the same thing as 2 times 3. That's the factors. If you had xy held together, then that's x times y. If you had x squared, that would be x times x. Or if you had y to the fifth, it would be y times y times y times y times y. Those are factors. Okay, and a greatest common factor is the ability to realize that I'm going to take all of the numbers that are possible out, as well as all the letters that are possible from all of my terms. Okay, if your term doesn't have a letter in it, you can't factor a letter out of it. Okay, so very first problem. Now I'm going to start this off slow. So this is going to be 2 and then x plus 8 is 2 times 2 times 2. Okay, I'm not done with the problem, but do you agree so far with the math that's up there? And 2 and x are being multiplied together, so I can put a times right there. Okay? So is there any number between our two terms that we could factor out? A 2. So you could factor that 2 out. If you factor a 2 out of 2x, you're left with x. If you factor a 2 out of 2 times 2 times 2, that leaves you just 2 times 2, which is 4. Okay, so this problem is this factored out. I've just undone the multiplication that would have gotten there. Okay, if I redistribute over, I'd get 2 times x, which is 2x, great, and then 2 times 4, which is 8. Second problem. This is the same thing as 3 times x, and then 12 is the same thing as 3 times 2 times 2. 3 times 2 is 6, times another 2 is 12. What do I have in common on here that I can factor out of both terms? Yeah. It's a minus. What do I have in common between those two? 3. Are we just slow because we've been off for the past couple of days, or are we struggling too much with what this is? I hope you're not struggling too much. If so, you need to switch your math class. Okay? Problem number 3, x squared. X squared is the same thing as x times x. Agree? So I get x times x plus 5 times x. What do I have in common between those two terms? I have a 5 on the first thing? X. Okay, so I have an x that I can factor out. And if I factor an x out of both of those, I'm left with an x plus 5. So again, you're undoing what we had been doing. We're going backwards from what we were doing. So, and then the last one, I have 3 times x times y plus 2 times y. What do I have in common between those two terms? Take a cautious look up there. I have 3xy as one term, and I have 2y as another term. So do both terms have 3? Do both terms have an x? Do both terms have y?
Yes.
Good. So that's going to give me y, and then 3x plus 2. Okay, so these are all the answers. That's a 4. Or excuse before, but we'll love it no matter what. So we're just undoing, we're like undistributing. Is that okay so far? Any question about what we've done so far? May I move to the next slide? Okay. So problem number 5. Let's write out what we have. 4 is the same thing as 2 times 2. Do you agree? And x squared is the same thing as x times x. Agree? Minus 2 times x. Okay? So numerically, is there a number we have in common between both of them? Yeah, I have a 2. As far as letters go, do I have the same letter between the two? I have an x. So what do you think I would factor out of both of those? An x and a 2. So that x and a 2 is 2x, right? What do I have left if I factor out a 2 and an x right here? A 2 and an x minus, if I factor everything out, what has to be as a placeholder? 0 times what is, okay, gotta be a 1. 1's always a placeholder. 0 is never going to be the answer in here. I'm just going to tell you that. You're not going to come to it. Okay, even when it's raised to the 0 power, it's still going to be 1. Okay, so let's think about this. Could we logically make that 2 times x times 2 times x is 4x squared, and 2 times x times negative 1 is negative 2x? Does that make sense? So we're undoing the property. So let's take a look at this next one. I'll write this down here. So I have 2x, x minus 2 times 2, x minus 2 times 2 times 2 times x. So let me just pause. Does that make sense that we broke that down? Why did I break 8 down to 2 times 2 times 2? Because I'm in my very basic components. Okay, so 2x to the third, that's 2x. You multiply. If I break up 4x squared, that's 2 times 2 times x times x. And if I break 8 up, I get 2 times 2 times 2 times x. Notice I left the subtraction sign subtraction. I didn't take any of those out. Agree? So I have 3 terms up there now. I have 2x to the third was one of the terms, which is 2x. I have negative 4x squared, which is negative 2 times x times x. And my third term is negative 8x, which is negative 2 times negative 2, or negative 2 times 2 times 2 times x. Agree? All right. Do all 3 terms have a 2 in common? Do all 3 terms have an x in common? Can I factor anything more than a 2 and an x out of all 3 of those terms? Let's take a look at it. So, right now I have both of those in common, both of those in common, and both of those in common. Agree? So, let's do that. So I get 2x. What do I have left here? Xx, which is? X squared. The minus sign comes along. What do I have left here? Careful. I took a 2x out. I have this.
Oh,
Negative
Negative 2x. Okay. What about this one? I have that and that. Negative 4. Done. What other x? Because what I did is I took out an x. I took a 2x out. That's there. I took a 2x out. That's there. And I took a 2x out. So what do I have left? I have xx, which is x squared. Negative 200x is negative 2x. Negative 2 times 2, which is negative 4. You're just undoing. Okay, I'm going to squeak this down and give us a little more room for number 7. Did anyone need more time writing that? You okay? All right, so I'm going to look at this one now. Bringing this down here. So I can't break 3 down any further, so it's just 3. X squared is xx, agree? Y squared is yy, plus, break 6 down. 3 times 2, okay? X, yy, because y squared is yy. Okay? Do I have a number in common between my two terms? What is it? 3. So I have a 3 and a 3. Are there any other numbers that I have between those two terms? No. How many x's could I take out of both? Why only one? There's only one right there. There happens to be 2 over here, so we got to pick one of them to come out. How many y's can I factor out of both? 2 of them. I got yy and I got yy. Agree?
Yeah.
So what did I factor out of both terms? 3 and a x and a y squared. Good. So I got a 3x and a y squared I factored out of both terms. Looking right here, what do I have left? Just right here. X. Plus sign comes down. What do I have left here? 2. Done. What do you think? If you take your time with it, I promise you're going to get it. Okay? Can we go one more? Can I move off this screen? Everyone good? All right. Ooh. Problem number 8. Now let's pause for a minute. Let's just pause for a minute. Problem number 8 looks kind of different. So right now I have 2 terms on number 8. My first term is x and then quantity x minus 2. That's my first term. For the other term, I have 5 and then quantity x minus 2. Do I have a quantity that is the same between the two? Yeah, x minus 2, right? They both, of the 2 terms, so here's my first term and here's my second term. Of those, I have this and this. That's the exact same, agree? So I'm going to have x minus 2. So a whole binomial is a factor. What do I have left if I factor out an x minus 2 out of here, right here? Yeah, it's going to be x plus 5 is the whole answer. But right here, it's just have an x, right? And then you have this plus 5 as well. So take a look. This x here and this x here are the same. This 5 here and this 5 here are the same. Where did the x minus 2? They had it in common between it. We factored out a whole binomial first. So let's use that exact same principle here on number 9. I have 2 terms. My first term is 4 parentheses x plus 3. Agree? My second term is negative x squared times quantity x plus 3. So is there a binomial they both have in common? Which is? Yeah, x plus 3, this, and this come out. X plus 3. What do I have left on this if I took an x plus 3 out? 4. The minus sign comes down. What do I have left here? X squared. There's your answer. Now, I'm going to put a little disclaimer with this. I would totally accept that answer right now, but the 4 minus x squared will actually be something that will factor out later. It's called the difference of two squares. I think we've talked about it a little bit, but we'll hit it upon it right now. All right, as of right now, x plus 3 and then 4 minus x squared, totally fine. But just put a little underline under your 4 minus x squared to realize that would indeed factor out a little bit further. So we've been able to factor out a number from all of our terms. We've been able to factor out a letter from all of our terms. We've been able to factor out a letter and a number. And we've also been able to factor out a binomial. How many more slides I got? 9? Or is that done?
You're done.
Done?
No.
No. Really?
No. We have like trinomial, quad.
No, but as far as the notes go,
Yeah.
Yeah.
We're done.
that's it?
Yep. Yep.
No kidding?
No kidding.
Okay. Okay. So that was the last. Oh boy, oh boy. All right. All right. So, guys and girls, I will tell you that this stuff, if you stay with it, it's going to make a lot of sense. If you are the student that gets your name at the top of your homework and you come to class and it's blank, you're like, oh, I don't get any of this. You're going to continue the rest of the school year going, oh, I don't get any of this. And then you get to repeat the entire school year. Yeah, I already signed up for CP Geometry. Yeah, I go back in at the very end of the school year, and any Fs that sign up for CP Geometry get to have this count as their red-shirted year, and they get to take CP Algebra 1 over again. Yeah, that's the same idea. Yes. If you failed, yes. We always will re-sign you up for a class to take next year. If you happen to take summer school, then we'll change it. We don't take the gamble that you would take summer school and get credit for it right away. There's been too many kids saying, oh, but I'm going to go to summer school. So we say now, okay, once you go to summer school, you show us, we'll see your transcript right away, then we'll switch it next year.
So does that mean that
That I don't know about. I don't know about the English department, how they work that. I know in math we would probably allow somebody who is doing CP Algebra 1 a second time. If they took CP Geometry at the same time, I think sometimes that might go. But I don't know if there's always a lot of room in your schedule to do it. Plus, who wants 2 math classes? Yeah. I don't, but you can run down to the restroom if you need to. I apologize. Or you can just use your sleep. Sorry about that. All right. So let me give you all the opportunity to start on this. If you don't have it, take a picture with your phone and put it on a blank sheet of paper. So page 47 and page 48. You have plenty of time to start on it. Try it. See if you can figure it out. It's exactly what we just lectured on. So refer back to your notes. Let me get the video